goal of this lecture, today I will say 2 questions of linear algebra of CSIR net just as a review. Because I have told you many times linear algebra, this topic actually very important for higher study. Okay, let's see one question which had come in CSIR net exam. This type of question actually basic question but very knowledgeable question. Okay, see question which had come CSIR net June 2024 exam. The question is, let A be 10 cross 10 matrix. Assume that rank of A is 7. Then which of the following statement is necessary true? Option 1, there exists a vector V belongs to R10 such that AV not equal to 0 and A square V equal to 0. Option 2, there exists a vector V belongs to R10 such that A square V not equal to 0. And option 3, A must have a non-zero eigenvalue, and option 4, A to the power 7 equal to 0. At first I will see the option C. Here given A is 7 cross 7 matrix, 10 cross 10 matrix with rank 7. For this, if we consider such type of matrix, since A is 10 cross 10 matrix, assume that rank of A is 7, then A is, if diagonal element are 1, 1, 1, since rank of A is 7, 1, 1, 1, 2, 3, 4, 5, 6, 7, and other would be 0, 0, 0, and here other part is 0. Notice here A is 10 cross 10 matrix and rank of A equal to 7. Notice for this matrix A square equal to A. That means this is actually idempotent matrix. But since A square equal to A, so A to the power 7, for this type of matrix, obviously A to the power 7 would be not equal to 0. So option 4 is a wrong option, A to the power 7 equal to 0. By this type of matrix, we can delete this option. And option 1, there exists a vector V belongs to R10 such that AV not equal to 0 and A square V equal to 0. Since there exists a vector V belongs to R10 such that AV not equal to 0. And since AV not equal to 0 and since the matrix is idempotent matrix, that means A square equal to A, if we consider this type of matrix, then obviously that imply A square V would be not equal to 0. So if we consider this type of idempotent matrix, then I will say if AB not equal to 0, that imply A square V also not equal to 0. So by this construction we can delete option 1 is wrong. There exists a vector V belongs to R10 such that AV not equal to 0 and A square V equal to 0. Next I will see A must have non-zero eigenvalue. Is it true option? For this, consider a nilpotent matrix with nilpotent block of order 8 cross 8. That means that imply the minimal polynomial of this matrix would be x to the power 8 equal to 0. That means since this is the nilpotent matrix with nilpotent block 8 cross 8, that means rank would be, if we consider the matrix is B, rank of B would be 7. So obviously For this type of matrix, if we consider nilpotent matrix with nilpotent block of order 8 cross 8, obviously for this type of matrix always eigenvalue would be 0. So option 3 we can delete by this construction. Here A must have a non-zero eigenvalue. This is wrong. And option 2 imply there exists a vector V belongs to R10 such that A square V not equal to 0. Is it true option? For this, since given rank of A equal to 7, and here the question about A square V, so we all of us know rank of A square less than equal to minimum of rank of A comma rank of A, and this is maximum of rank of A plus rank of A minus N. That means this is less than equal to 7 and this is greater than equal to 7 plus 7 minus 10. That means this is greater than equal to 4. So rank of A square would be greater than equal to 4, less than equal to 7. For this always there exists a vector V. Such type of vector V belongs to R10. For this type of, since rank of A square would be greater than equal to 4 and less than equal to 7, so there exists always a vector V belongs to R10 such that A square V not equal to 0. So option 2 is a right option. I hope my all viewers have understood this type of question. This type of question actually very important for any competitive exam. Next example, for a variable x, consider R vector space where V equal to A0 plus A1x plus A2x square, where A0, A1, A2 belongs to R. And consider one linear transformation T from vector space to vector space, which is defined by T of f equal to f plus d of df dx, where df dx is denote the derivative of f with respect to x. Then which of the following statement is true? Option 1, t cube minus 3t square plus 3t to the power 2025 x equal to x. Option 2, t cube minus 3t square plus 3t to the power 2025 x equal to x plus 1. Option 3, t cube minus 3t square plus 3t to the power 2025 x equal to 2025 factorial times x. Option 4, t cube minus 3t square plus 3t to the power 2025 x equal to 2025 factorial x plus 1. Here this is means actually we have to prove the identity operator. Now let's see which of the following are true. Since here V is generated by 3 bases, so dimension of V equal to 3. So since T be a mapping from vector space to vector space, so with respect to this linear transformation, the matrix would be always 3 cross 3 types. And here TF equal to A plus DF dx. So actually we have to find the matrix representation with respect to the basis 1x x square. Okay. So for first basis T of 1 equal to 1. Second T of x equal to x plus 1. Then would be T of x square equal to x square plus 2x. Then the matrix representation would be, so the matrix representation would be 1 0 0 1 1 0. Here would be 0 2 1. This is the matrix representation. Here the base is 1 x square, and here the base is 1 x square. This is the matrix representation. And notice, since this is the upper triangular matrix, so always the eigenvalue of upper triangular matrix, we all of us know diagonal entries. So the eigenvalue are 1, 1, 1. For this, the characteristic polynomial would be t minus 1 whole cube equal to 0. That implies t minus identity whole cube equal to 0. That implies t cube minus identity minus 3t square plus 3t equal to 0. That implies t cube minus 3t square plus 3t equal to identity. I hope my all viewers have understood. That means here the operator would be, this is actually the given operator, t cube minus 3t square plus 3t. That means since this is the identity operator, so t cube minus 3t square plus 3t to the power 225, this is, sorry, 2025, this would be identity to the power 2025, that means this is actually identity. So t cube minus 3t square plus 3tx equal to always x. So option 1 is a right option. Option 2 is a wrong. X plus 1, x would be x plus 1. Similarly, option 3, option 4 is a wrong option. I hope my all viewers have understood this type of question. This is actually matrix representation. Okay? Well. Next question. For a variable x, consider the Q vector space V equal to a xr cube plus b x square plus cx plus d, where a, b, c, d belongs to Q. Now consider the function a, which is defined from a function from V to Q, where f is a Q linear transformation and b is the set such that f belongs to a such that f of 1 equal to 0. Then which of the following statement is true? Option 1. If f belongs to b, then dimension of kernel f is equal to 3. Option 2. Dimension of b equal to 3. Option 3. Dimension of a equal to 4. And option 4. If f belongs to a, then image of f is one dimensional vector, Q vector space. At first I will say option 4. If f belongs to a, where a is the mapping f from V to Q, where f is a Q linear transformation, what is the dimension of a? We all of us know that b is generated by the polynomial a xr cube plus b x square plus cx plus d, where a, b, c, d belongs to Q. That means here this is equal to actually q3x over q. Then dimension of v is equal to, since this is generated by 1x x squared xr cube, so dimension of v equal to actually 4 and q over q, this dimension is 1. So the function which map from V to Q, the dimension is, here f be a function which mapping from B to Q, where f is a Q linear transformation which is equal to actually the linear transformation V to Q. Then dimension of a, actually dimension of a linear transformation from V to Q, which is equal to dimension of V over Q times dimension of Q over Q, and dimension of V over Q is 4, and we all of us know dimension of Q over Q, always this dimension is 1, dimension of Q over Q always be 1, because we can generate Q over Q by the vector 1 and which is linearly independent vector. So we all of us know dimension of Q over Q, dimension of R over R, dimension of C over C. This dimension is actually 1. So this value is 4. Okay. So dimension of A is 4. And notice dimension of B. Dimension of B is such linear transformation belongs to A, but here f of 1 equal to 0. That means there exists one restriction. And we all of us know when there exists a restriction, then this dimension would be B equal to f belongs to A such that f of 1 equal to 0. And obviously B is a subspace of A. And dimension of B equal to dimension of A minus number of linearly independent restriction. Since here one restriction, so this would be 4 minus 1 equal to 3. So dimension of B equal to 3. So option 2 is a right option. Then I will see option 4. If f belongs to A, then image of f is one-dimensional Q vector space. Is it true? F belongs to A, then the question, the image of f is one-dimensional. Image of f means obviously f of px, where px belongs to V. If we consider zero transformation, then actually would be f of px equal to 0. Okay. That imply for this image, dimension of image f over q, since here image f would be q vector space, is 1, since this is zero transformation. Okay. So for this transformation, image of f is one-dimensional vector space. This is wrong. Here, since this is the zero transformation, so this is the subspace of this linear transformation f from V to Q. So, and its dimension is actually 0. Option 4 is a wrong option. If f belongs to A, this image is one-dimensional Q vector space. This is wrong option for zero transformation. And option 1, if f belongs to B, then dimension of kernel f is equal to 3. Is it true? Similarly, if we consider f be a zero linear transformation in A, that imply f of px equal to 0, and this is true for all px belongs to V. That means if f belongs to B, then dimension of kernel f is equal to 3. Is it true? Since B means f of 1 equal to 0, so if f of px equal to 0, this is true for all px. That means obviously f of 1 equal to also 0, that means f belongs to B. So our construction is right, f belongs to B. Then what is the dimension of kernel of f? Dimension of ker f equal to whole px, which is belongs to V. That means dimension of kernel f equal to actually dimension of V, and dimension of V is 4. So dimension of kernel of f is 3. This is wrong. Only 2 and 3 is the right option. I hope my all viewers have understood this is clearly. Okay, OA. Today I will stop here. In my next video, I will discuss some more question about linear algebra. Actually, linear algebra, this topic is very important for any competitive exam. Okay. If you have any queries about this video, please do comments in comments box. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.